As we look at the massive AI boom that's sweeping across the globe, what does it actually take from a physical standpoint to keep all of these models running? Why are submarine cable operators building networks just in case a surge of traffic arrives? And how is local power grid availability dictating exactly where the next major hubs are going to be built? What role are legacy crypto mining data centers playing now in AI infrastructure? Welcome to TeleGeography Explains the Internet, the show that explores the business behind all of the ways humans stay connected around the world. I'm your host, Greg Bryan, and my guests today are a trio of TeleGeography's very own experts closing out our multi-part series on the impacts of AI on global telecom. We're sitting down with Alan Mauldin, Patrick Christian, and Jon Hjembo to tie together network, cloud, and data center into this complicated infrastructure puzzle. In this capstone episode, we weave together three telegeography research areas that have direct impacts on each other and the expansion of AI services. We'll look at the long-haul network buffer. Alan provides a crucial perspective on international bandwidth demand, reminding us that heavy networks cannot move at the speed of software. He explains why providers are securing fiber right now, sometimes purely as a risk mitigation strategy against future uncertainty. We'll look at the rise of neoclouds, or GPU as a service. Patrick breaks down how a post-ChatGPT surge overwhelmed the hyperscalers, leading to a boom in specialized neocloud providers, many of which evolved from legacy crypto mining facilities, which are located far from population centers, and that becomes important. Finally, we'll look at data center realities and power grids. Jon takes us inside the data center, revealing how a 35% pipeline surge between 2024 and 2025 has collided with intense local regulatory, water, and power bottlenecks in markets ranging from Dublin to Malaysia. We also dive into the fascinating Pax Silica geopolitical chip alliance. This is a really interesting multi-layered look at how the AI explosion is actively shaping and being shaped by the physical realities of global infrastructure, and importantly includes information that telegeography is actively tracking in the market so that everyone can better understand how all of this works together. Before we get to the interviews, though, I have a quick announcement that I'm very excited to share. Basically, since the COVID years, I have been looking for intimate events that are laser focused on issues in enterprise networks. And to that end, I am very excited to announce that we will be partnering with Lightyear for their event, Layer 8. Layer 8 will be happening on November 4th of this year at the Arlo Williamsburg in New York City. It is designed for enterprise WAN operators, network engineers, and other IT infrastructure leaders. This will be a practitioner-first, full-day event built around the people who actually run enterprise networks, not built around vendors. The content tracks cover the future of enterprise WAN, AI-powered network operations, and network optimization and design. Crucially, attendance is free for all enterprise end users. We will have a link in our blog post for this episode to register with Layer 8. And I'm very happy to announce that TeleGeography is a leading sponsor, as we will help shape the content with sessions going live this July. So keep an eye out. I will be there, and I would love to catch up with you at the event. Okay, if you enjoyed this episode, please take a moment to rate the show, subscribe on your favorite platform, and tell a friend to listen. As always, find me on LinkedIn, and there share your suggestions, questions, and feedback. All right, let's get to it. Welcome back to the show, Alan.
Thanks, Greg. Happy to be here. It's my third or fourth time. It's a real treat as always.
Yeah, exactly. We had you on not too long ago, like almost a year ago by the time this comes out, on our submarine cable maintenance study and encouraging the industry to get more repair vessels. But since especially you were on with a co-guest on that one, could you remind listeners what it is that you are in charge of at TeleGeography?
Yeah, so I lead TeleGeography's research on network infrastructure, so encompassing a wide array of things from submarine cables, IP networks, things like this.
Hmm. Yeah, often when I'm introducing telegeography, tell people that broadly speaking, we have three kind of study areas: your consumer retail oriented stuff from our UK office, and then our DC office, which is actually spread all across the world, is split between sort of pricing and infrastructure, and that's your part of this, right? So,
That's right.
and that is why I'm having you on today. I'm going to talk specifically about not our whole infrastructure research area, but a specific product line within that of transport networks. And as you know, this is a part of our series all about the impacts of AI on telecoms. And something that I have emphasized in a lot of these conversations, maybe almost all of them in this series, has been that while data centers get so much of the attention, both in the general public as well as really within the industry, of course, transport networks have to be connected to all of those data centers to make them do anything, and might be, I think, a crucial bottleneck for AI, not just power availability and data center construction, but connecting those data centers. Is that your take as well?
Yeah, absolutely right. I think the headline for the data center component is warranted because it's the most expensive part. The power and the data
Hmm.
centers and the chips, hugely expensive, but without the networks to link them to each other and to end users, they're kind of useless, right? So you definitely need to see both the data centers and power scaling with networks as well. So it's definitely a key thing happening at the same time, really around the world right now.
Yeah, absolutely. And I think too often still, again, even within the industry, that sort of network is taken for granted. I've told this story many times, but I was on a panel at a data center oriented conference last fall and sort of made this comment that like, oh, you find the right place in a rural area to drop a data center and there's power and that sort of thing. But then there's no fiber networks connecting to it. And someone else on the panel is like, ah, you dig some trenches and lay some fiber. And okay, well, it's not quite that easy. Transport networks are important. There are other aspects to think about other than just we could lay some fiber down to the data center, right? So, yeah. So what I want to focus on here today, Alan, is to sort of look at what we in our research, because we've been looking at transport networks since we published them in physical books. I remember that, as I know you
Yeah,
do,
sure.
for more than 20 years, like 25 years even.
Yeah.
And so AI is the sort of hot topic to come along at these kinds of trends that we've been looking at forever. But can we, in that research that we've been doing for decades, sort of tease out the impact of AI on transport networks?
Yeah, so I think there's a few ways you can go about looking at this, and one is AI traffic. It is one part of the overall traffic being carried by these networks, right? There's not AI specific subsea cables, at least not yet, right? They're just
Yeah.
they're an application that's also being carried alongside cloud and streaming or all these other things that are being used for the network, which are absolutely massive. And AI traffic, is growing very fast, but it's just one component of that. And so also when you think about where AI is going to be located, the AI factories,
Mm.
if you will, is that where we see networks being located as well and our cables being built, let's say, to serve just those locations, so that's
Hmm.
that's how you could see some of the impacts playing out. But a lot of the research that we have, these are the inputs for AI. So when we talk about like what's the price of a 400 gig wavelength, the neo clouds are buying these in on long haul networks to link together their facilities. So there is an AI impact, in this in a way, right? They are
Right.
fueling the need for higher capacity circuits to link their facilities to each other, and ultimately it just raises the bandwidth demand,
Hmm.
around the world. I mean, it's still growing very fast. I think on a previous episode, you said we're still seeing Moore's law growth. Well, we're not seeing that actually, right? We don't
Mm.
see
Hmm.
Moore's law level growth for international bandwidth demand and haven't for quite some time. Just as a reminder, Moore's law is a doubling every 2 years.
Right.
That equates to like a 41% annual growth rate. We
Wow.
don't
Which
really
is
see that
massive
happening.
at,
Yeah,
yeah, the kind of
it's
numbers that we have now, that would be unthinkable almost,
it's
right? So yeah.
incredibly huge, right? So that's happening like maybe in some parts of Africa still, but we're seeing,
Mhm.
only like, 25, 30. So I think 20, like 26 or 27% is a doubling every 3 years. So
Mhm.
it's like people might think, oh, 25% is pretty low. It's absolutely massive. We're growing from
Right.
a very huge, huge base as well. So even, 20%, 25, right? We're getting huge numbers around the world of bandwidth
Yeah.
that's being added each year to networks.
Right. Yeah. Yeah. I've had to recently explain this kind of phenomenon, math, in the other direction, which is in falling prices, right?
Mm,
That people would look at how quickly, say, DIA or wavelength, it applies pretty similarly. Prices are falling in certain places in the world. And historically, I would always say, oh, expect something like 15, 20, 25% even declines on average annually. But when you get down to really low prices, you can't keep seeing those kinds of declines, right? So just when you were already at rock bottom prices, if you kept declining that much, then you'd quickly approach zero, let alone your cost basis, right? So you have to understand growth as a relationship to the actual numbers. But I want to back up then a little bit and just have you explain to the audience what exactly we do track in transport networks that you would want to be
sure.
able to see these trends out of.
So we're tracking data on the long haul providers of fiber, both terrestrially and submarine cables, existing and planned networks, the capacity of them. We're tracking the amount of used international bandwidth that's been deployed by different kinds of operators. We have data historically back to 2005 and forecasts for the next 10 years as well on a basis of country to country, region to region, et cetera. We also have something new we added just last month, which is forecast of the numbers of new submarine cables needed for various routes for the next 10 years. We have analysis of the market trends, the drivers for content providers, AI, pricing trends as well. We have data on latency for subsea cables as well. And we also track data that we can get that is found publicly available on submarine cable faults, a database of that for the last 6 7 years, showing which cables have had faults and how long it took to repair them. So a lot of different types of data that really impact the whole industry in many different ways. And the coverage is global, right? We don't just cover the US or Europe. It's really a globally focused research service that we offer.
Right, which I think is what makes what we do at telegeography different than folks who do some similar things, is that we've always had that focus. Our granularity is global, so I get asked all the time, I'm sure you do too, like for things like, oh, do you track like KMZ files of exactly where a fiber is going down this street in Manhattan or whatever? And that's not the kind of thing we do. We're looking at this sort of more macro scale of where everything is located and that sort of thing. And in that light, I've been thinking about this, and I want you to correct me as the expert if I'm wrong, or where you see this in parallel with what you do. That when we're talking about AI, because that's what everyone wants to talk about, and it's because it is, like, no doubt what's impacting the industry right now, that it seemed to me, especially early on, that carriers, the folks managing these long haul or even sort of more metro oriented networks, kind of only have a few dials available to them when it comes to the AI. Right? There's only a few ways that this impacts them, which is bandwidth demand. Right? It can increase bandwidth demand, latency. There might be applications that require a different latency, and then the third one has been sort of more emerging for me over time, but it's core, I think, to what we do at telegeography, is the center of gravity of the networks, right? So that's a little bit more vague one, but thinking about the geography of networks and how that needs to change, and we've tracked that, of course, over the years.
Yeah.
But yeah, I see this as kind of the three dials that carriers have to play with in terms of, like, as we see AI unfold, how it impacts our industry.
I think the biggest question that I get asked, well, there's several. One of them is like, how is AI going to how is AI going to impact the demand for long haul bandwidth?
Hmm.
And the answer that everybody tells
Exactly.
us is, uh, it's not clear yet. We don't know. It
Right.
depends. There's
Yeah.
just a lot of kind of not clarity, no clarity around it. But what we can say is what it could depend upon, which
Mm.
heavily is,
Great point.
where's the location of this stuff going to happen? But by stuff, I mean, where are we going to have AI training?
Yeah.
Where are we going to, is it going to be spread across many different locations? I mean, right now there's limits to how far apart you can do some AI training, but Google has announced something recently, like last month, I think it's called decoupled diloco, where you could do distributed training, right? And it doesn't require you to have very close proximity of things. So can that scale, longer distances? I don't know. I'm not an AI expert, but there's things
Hmm.
that how training is being done is evolving, right? And then with inference, like, so where's it going to be? Where are the chips available that you need? Where's the power available for those chips? Where's the data center space? What applications need what kind of inference too, right? It's not as though inference is like a singular thing. There is some that needs to be, on your device, right? Some is going to be in an edge data center, and some is going to be maybe in a bigger facility in the core of the network, right? So there's not a single answer to this. So people want a simple answer to a complicated question that doesn't really exist. But and I think it depends on also the adoption rate of AI. Like, how are we going to use this ultimately, and how will it be
Hmm.
adopted by different countries, different user bases? It could be that, in the U.S., for example, you create very little international demand and long haul because a lot of stuff is just localized. But if you're in, the Philippines, let's say, does your AI use cause demand across
Mm.
cables going to Japan, to the
Hmm.
U.S., Singapore? But does that change over time as more AI compute is deployed locally, right? So it could be like cloud, where you see like more is, it starts off being, cloud was in a few major regions. Now it's more diffused. So where you access cloud is becoming near to you, and AI could become the same way. It comes near to you over time, possibly. This is all just speculation. Like, I don't understand how this works fully, so I'm not an expert at all.
Right.
I just love to talk
Well,
about it and read about
does
it and learn
anybody?
about this stuff.
Right?
Yeah,
Yeah. I
super
think
interesting.
a hallmark of the IT industry in general, which I'm looping telecom in under that general umbrella, is that everyone tends to work on a little piece of it that they understand extremely well and very few other people do, but it's really hard to understand how it all works in concert. So
That's so
I
true,
think that
Greg. That is so
yeah.
true. Yeah,
Yeah.
I mean, it's just really interesting to think about the things that these global networks do, right. Like, for example, I like to think about Google and Meta's global networks as massive AI training data collection engines.
Agree.
They're gathering up all this data on user behavior, what you do, and yeah, they're going to sell ads to you. They're also going to train their models on this constantly, right? So part of what they're doing with their networks is to suck up all this data. I mean, they aren't alone in doing this, of course, but that's
Mhm.
one function of these global networks is not, AI services itself, right? The AI driven traffic, but it's the ingest of the AI training data.
Mhm. That's a great point. So one of the ways I've often been thinking about this is because I focus on enterprise networks, right? Is from the enterprise adoption standpoint. We don't know what the sort of killer app or apps might be for AI for enterprise adoption, right? But the impact on the network is going to have a lot to do with, like, whose data is it and how far away from the source can that data go, right? So if enterprises have to
Absolutely.
keep their data sovereignty, and then that inference has to involve like a lower latency, that's going to shift some of the center of gravity of the network. We had Hunter Newby on talking about his vision
Yes.
of pushing GPUs towards the users and those kinds of things. But I like what you said about thinking about it from a much more macro scale, again, of thinking, like, where the models are created even matters, and then having to push those models. If you're in a place where the models haven't been created, that's going to impact international demand. But that made me think about, we have this really cool map of cloud on-ramp development over time, where you can pull this slider and see, sort of where the cloud instances were in each year going back to like 2008 or some maybe earlier, right?
Yeah.
And and if I were to think about transport networks with how that map looked in 2010, right, it would be a really different world than how that map looks in 2026, right? And so I think that's a difficulty in understanding what the future is going to look like, right?
Yeah, for sure. I think this also goes back to the issue of where will each part of AI be located? I mean, with the
Mm-hmm.
where is inference done, where is training done, and all these things. And I think what we're seeing now is a pivot towards a focus on efficiency, really.
Right.
And I was reading something the other day about like one of the metrics that should be captured here is like the value generated like per watt or something. It's like that's how we should view things, and that's whoever I think it was the CEO
Yeah.
of Perplexity who said whoever will win in AI will have the most compelling the lowest cost per
Right.
AI knowledge generated, which is interesting because you can't keep scaling power indefinitely, right? There's going to be a limit to the stuff, and
Yeah.
right now there's already limits in how fast we can deploy these, how fast we can add power. There's also limits of how fast we can deploy networks, right? If you wanted to add a new subsea cable today, you're looking at least 4 years, right?
Right.
It just takes that long to build a cable. So it does provide a bit of a break on seeing an overbuild happen, right? You can't just put down 5 new cables in the Atlantic in 1 year, right? It have be phased in over time. Um, so it's interesting to see how are we going to see this efficiency of AI emerging
This is
in
an
terms of the
excellent
power.
point.
I mean, yeah.
So I saw an article the other day that was essentially saying, like, at this point in time, an AI agent costs more than a human doing the work often, right? You know what I mean? So
Exactly.
so
Exactly.
and
Yeah.
and I think too many people see that as a software problem ultimately, like as a technical problem, whereas what you're saying is that it's an infrastructure problem, right? All of this requires heavy infrastructure that has shortages in terms of the labor to build the infrastructure, the supplies for the infrastructure. If people need massive amounts of bandwidth, there's only, Corning and Prysmian and a few other suppliers that even make fiber, for one thing. And all of these things are really, and here's something that doesn't often happen on TeleGeography Explains the Internet, but I think, take it as you will, right? We're not giving advice, but someone who's interested in investing in these things can think about this aspect, that who wins the AI game might have more to do with their infrastructure efficiency necessarily than the development of the agents themselves in many respects, right? So
Yeah, for sure. I would also mention there was an article this last week in the Wall Street Journal. I think it was called "The Hallucinatory AI Math," and it was great
mm-hmm.
for what we talk about because it was comparing the undersea cable boom of the late '90s to the current AI boom, and the,
Right.
the comparison here was that the demand was real for both the subsea cable demand and the AI demand. It's real. Like that wasn't the problem. What happened was higher prices didn't persist. So
Right.
the prices of bandwidth across the Atlantic used to be like like $10 million for a DS3, things like
Yeah.
crazy obscene prices, and the prices collapsed, but demand soared and kept on soaring, and so there was a bit of a squeeze there, a misalignment of what you thought you could get for your bandwidth versus the value. So with AI, the article was proposing we're on a similar path where we're going to see some of these higher priced AI services will start coming down a bit, and how's that going to impact the entire market? And one thing that I also read about recently that was interesting was, as you mentioned, the cost of some of these AI services, the cost of inferencing. People are spending millions and millions of dollars a month, blowing through their budget for the whole year, like in a month, right? Um, you could see companies just trying to run their own GPUs locally with their own data. You
That's a
don't
great point.
have to use Anthropic or OpenAI or Google. I mean, maybe for certain applications you would need to use more advanced models. But so you could see more of a, I guess the akin with cloud would be a, what do you call it, a repatriation, right? Is that what it is, where you move stuff from the
That's
cloud
what we
back
call it in,
locally?
yeah. Yep,
Okay,
exactly.
so
And that was
there's
already,
that.
just to be clear too, there was a trend toward cloud repatriation before AI came along,
Hmm.
partly for some of the same reasons that the ingress and egress costs at cloud were more than people thought. So there, it's not, complete or whatever, but there was a certain pulling back from, hey, we should do everything in the cloud, to like, oh, maybe it's not the worst thing to have some servers back on campus. That's so.
Yeah, and I'm not trying to suggest that this is going to then obviate the need to have any kind of long haul
Of
networks
course,
to
yeah,
serve AI models remotely
but
housed
it'll
in
impact,
massive
yeah.
AI factories or anything. But
Hmm.
you just
Well, and we mentioned before, but you didn't mention in that part that there's other issues too that might also drive that. Not just the cost. Costs are always a big driver, right? But data sovereignty, for example, it might benefit enterprises to take the ideas of models and build their own LLMs or whatever on campus, because they don't want their data mixing in with anybody else's data. And they're obviously the AI companies have ways of dealing with this, but there's nothing like not sharing your data at all, right? So yeah.
sure.
So Alan, I want to ask you a kind of analyst philosophical question here, which is that, given there's like a lot of unknowns here, and our research has been looking at some of these same trends over time, which is what makes it so powerful to be able to see these same things over time. But if you could find out more about sort of how AI will impact networks, what kinds of data would you like to be able to capture out there? It's one of the things that people come to us all the time. I'm sure you have this experience, asking us questions that I'm like, oh, those would be really cool to answer, but we have to do the research the way that we can, right? So.
So I mentioned first the most common question I'm asked, which is what's the impact of AI on long haul demand? The second most common question is how many megawatts of data center capacity equates to the need for how many terabits or number of fiber pairs of
I
bandwidth?
love it.
And
Yeah.
I'm not saying that I want this question answered, because I want people to stop asking me this question, because
Yeah.
it
Yeah.
can't be answered actually, because
Right.
the answer again is it depends on what kind of data center facility we're talking about. What's it
Right.
used for? Who are the users? Like, is it one facility is part of a domestic campus that's just serving like sovereign requirements? Is a data center that's part of a big global mesh for cloud services? I mean,
Hmm.
so people want a very simple answer to complicated questions always. That is just always true. So,
Yeah.
and I think the other issue is, as chips become more efficient, that plays a role here. So if it's a 10 megawatt facility, what does that actually mean? It's like,
In
well,
terms of
you
data
put in some new
generation, right?
chips that,
Yeah.
that can, I think the new Vera Rubin can do is 10x the performance, but it's only 2 times the power.
Hmm.
So, there's these things that you have to take into account of what's in that facility over time. How's it going to evolve, and how is AI itself done will evolve, and also other things that the facility is being used for besides AI. Right? There's still cloud. There's still other things that exist besides
Right.
AI that do need to have data center space, and the connectivity as well to them. So,
Hmm.
I mean, I would love if there was an answer. It'd be great to know the answer to that question of like, oh, you need to have 20 fiber pairs for every 10 megawatts or whatever.
Right.
People want that answer, right? But it
Hmm.
doesn't exist. But I think what we can learn from this question, though, is when you have uncertainty in the market, the most logical response actually is you build just in case, right? So a lot of what we hear about people, buying in the market, buying spectrum or pairs terrestrially and on subsea cables is not because they need it right now to fully let them activate it. They need it because they're not quite sure what they need, and the
Hmm.
cost of not acquiring it now is massive. So the downside risk of not having it is higher than would have cost you to acquire in the present, right? So
Right.
um, it's a bit of a paradox there of how you should think about the more uncertainty, the more certain you should be about trying to acquire capacity. But
Hmm.
there's something to that, I think.
Well, there's massive differences terrestrially than submarine cable wise, right? Because terrestrially, you dig a trench, you have something, poles, you can pass thousands of fiber pairs through those
Absolutely.
often,
Yeah.
right? Whereas we have a pretty hard limit in the submarine cable world, right? So
But even there, we do hear about some of the hyperscalers not just taking 4 to 8 pairs on a route anymore. I hear about them taking 48 pairs. Well, do they need
right.
to light up 48 right now on day one? Probably not. But there's a new overbuild that was done, and they just want to secure their long term supply, because also for them the cost of doing this, buying these pairs, it's kind of nothing compared to the cost they're spending for data centers and power and chips, right? It's a
Right.
small fraction, so they might as well go ahead and do it. Again,
Hmm.
if they don't have it and they need it, that's a bigger risk, right? But your point is correct with the subsea cables. Like you cannot go out and source 4 pairs on 4 paths in the Atlantic right now. Like you can't do
Right.
that. So if you want to do that kind of a build, you got to start now and think
Hmm.
about how am I going to build enough cables or partner with different companies to acquire the pairs to build out a big high capacity network. Because subsea cables, the pairs are limited, as you know. You get the max right now is 24 pairs per cable. So it's not as easy as it is to get access to terrestrial pairs.
Yeah, no, this is really interesting, and I think it's why there's so much concern about whether we're in a period like the early 2000s with the internet or whatever. But it's just really hard to know. I get asked a lot of the same similar questions, not the same ones as you, but similar questions around this, and it really does all come down to what AI actually ends up looking like, what kind of bandwidth demand it actually generates. I mean, to a certain extent, LLMs don't generate a lot of bandwidth demand, right? They're mostly text. So
Well, it
yeah,
depends on what you're
and
doing. Are you
that's
uploading a
it,
4K? Are you going to upload a 4K video and ask you then to take it and
right?
make it into a different 4K video for you and send it back to you? That's a
Hmm.
different thing than asking it to rewrite this
Yeah,
email for you,
yeah,
right?
and it's
Um,
easy to conceive of applications like a video agent that you interact with in real time that would very much be bandwidth and latency sensitive, right? So yeah.
so on the issue of is this a bubble, let's say, for AI, and how would it impact the demand
I didn't want to
for
say the B word.
network?
I'll let you say it.
I'll say it.
Yeah.
I mean,
Yeah.
it's always talked about in the submarine cable industry because everybody's worried about an overbuild happening, right? I think it's a fair question to ask, but we should remember that cables are carrying a ton of things that have nothing to do with AI right now,
Mm.
and
Yeah.
those things are still growing. They're still going at a rapid pace. So
Streaming, for
so
example.
AI
Yeah.
is going to keep on growing for sure, even if there's a market bubble and there's a repricing of the companies that are involved in this, right? That could have an implication for how fast they deploy future cables and networks terrestrially, right? But in terms of the underlying demand for the bandwidth, that's not really in question. I don't believe it's going to keep growing. We aren't in a case where it's like, oh, there's an AI bubble, demand goes to zero or anything. We're going to still see demand growing at a rather strong clip for the foreseeable future.
We saw demand growing very rapidly over the last several 2 decades at least, right? Long before AI was on the
The
buzzword, right?
market's been up and down during that whole time. I mean, a few years
Yeah.
ago, I tried to do a comparison of like the market cycle, the GDP growth or recessions versus the demand for bandwidth, and there's like zero correlation. It just demand keeps growing despite whatever's happening in the broader macroeconomic environment.
That's really interesting. I would like to look more deeply at that because
I'll send the
that
slides
makes
to you.
sense. Yeah, I would. Yeah, yeah, that would be great because when you think about it, in fact, there might be even some cases where demand actually increases during difficult economic times because digital things are so much cheaper than physical things in many respects, right? So yeah,
Well, you don't
that's
have to
really
go back
interesting.
very far to see that, Greg. You can go back
Yeah,
to COVID.
right, exactly.
Demand
Like,
soared because people couldn't get out of their house and travel, go to school, go to work. Right?
hmm
Markets were down for a bit.
yeah,
They rallied pretty quickly,
right,
but demand soared. So
yeah, yeah, exactly. Excellent. Well, Alan, it's been really interesting, but I'm not going to let you off the hook just yet until you talk. You have been touching on it, but a little bit more specifically, sort of forward looking. Like one of the things we do, of course, is forecast all of this. What is the rest of this a decade look like in your view for transport networks?
So I think one thing that's really, I think probably interesting that we're going to see is in terms of the number of cables that we see in the ocean on the major routes. Let's say the number has been fairly static the last 15 years because you had new cables coming, old ones would be retired. But right now, what we're seeing is the need for bandwidth is so strong, the ability to build higher capacity cables is slowing a bit. We
Hmm.
can't push more bandwidth per fiber pair because of Shannon's um, limit. So we're seeing more pairs per cable, right? But what this actually is pushing towards that we think is we're going to see, in the Atlantic, for example, like a doubling of the number of cables in the next 10 years. Not the number of
Hmm.
cables that are built, but the ones that are totally in service. So instead of having just
Ah, right.
14, 15 cable paths, you're going to have possibly 30 different paths. And a similar situation, in the Pacific as well, and other parts of the world, because there's just such a need for more cables and also a need for diversity. You have to go to different places.
Hmm.
You can't just have five cables on the same route, right? You don't have that. You have many different points to connect now, so it's just a huge increase in the number of cables that have to be maintained also, right? To go back to the thing that we wrote about last year, the cable
Right.
maintenance issues is um, more cables. So I think if you're in the business of building cables, things look pretty good for you for
Or
the
building
future
ships
right
that can
now.
build or fix cables too, right? So yeah, yeah.
Yeah, I don't think there's any, and people also worry about, won't satellites make the need for cables go away? It's like people don't
This
understand
question,
the
yeah.
the 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 capacity of a submarine cable is absolutely massive, and it
Yeah.
dwarfs what all the satellites can carry, right?
It's funny because I just saw an article yesterday where someone was sort of hot take on this AI bubble is going to be massive. They're going to put data centers in space and all this. And I'm like, data centers in space. Like, I'm sorry, but you really don't understand the massive difference between utilizing spectrum and the latency and the bandwidth versus utilizing fiber. There's just I
And
I
trying to
can't see.
dissipate heat in a
Yeah.
vacuum also.
Oh, there, that was
Small
another. I'm like,
details, small
hello. Like,
details, right?
I would
Yeah.
believe the data centers underwater long before I'd believe the data centers in space because at least you can dissipate heat into the water. Right? Not a great thing for the environment, just for the record. But, no, that's really interesting. So I'm a big geography nerd, as lots of us are, and there's in the sort of geography nerd world, there's kind of like a joke of there's only one map because no matter what phenomenon you map, it often correlates very strongly with population density, right?
Hmm.
Obviously, over the years, our transport maps have done so, but I do see maybe a little bit of a shift in that center of gravity, right, due to the AI, right? You know what I mean? So to your point, that there are currently, sort of maybe 15 or so cables transatlantic, and most of those are connecting New York and London to some degree. We've seen some expansion of that to alternative
Yeah,
connections.
absolutely.
So do you see that the center of gravity of the network is changing and will change a lot over the next decade?
I think somewhat. I mean, I think that the answer is like both can be true, right? We're going to
Of
see
course.
still see more cables on the major routes. These are where we've
Hmm.
traditionally seen a lot of cables. There's high demand between them. It's often the shortest route. It's often the route where you're able to uh, navigate the geopolitical environment to lay cables in
Yep.
in a certain way. But then also you do see the geopolitics leading to new routes being created. And then also you see just this need for extreme levels of route diversity, seeing new cables
Mhm.
being built along totally unique routes. I mean, Google's been the chief company doing this with cables between South Africa and Australia, Australia to
Mm.
South America, things like this that have never been done before. But they do create this complete global mesh we've never had before. So it's a really new thing to have
Yeah.
available to the world to use.
Yeah, if any listeners have never done this, we've always found it fascinating to compare our map of submarine cables to a map of international flights and international shipping lanes, right? And to look at the similarities there, it would be interesting to see if how much that sort of continues to persist. It'll always be the case, of course, but some sort of differences I think would be fascinating. Excellent. All right. Well, Alan, this has been really enlightening for me, even though I've been thinking about these things for a long time. So that's that's high praise. Thank you. Yeah.
Happy to chat as always, Greg.
Excellent. All right. Cheers. Coming up next, we'll have Patrick Christian to talk about the cloud that underlying transport network is connecting. Welcome back to the show, Patrick.
Great to be back, Greg. How did
And
you?
just realizing here that you're in France right now, not Japan, so that makes this a lot easier to do, and it's still daytime for you, so that's
It's
good, right?
still light out, so
Yeah,
that's good.
absolutely. So you were on the show fairly recently and have done several times before. But for anybody just tuning in, which we have a lot of people pop in and out based on the topic, right?
Mhm.
Tell us what you manage here at TeleGeography, please.
Sure. I manage the cloud and WAN research. So everything that is cloud, we track, and WAN as well. Although you do a lot more of the WAN side than I do, but I do some of the, I guess, the supply side of WAN.
Hmm. Hmm.
So we track cloud and cloud infrastructure, and with that, we're tracking, of course, a lot of AI at the moment.
Exactly, which is what we're here for, the sort of capstone to my several episode series all about AI. You know, it's funny because we started this series really like at the end of last year. And now I'm realizing that probably just every podcast I do from here on out will be about AI anyway.
Yes,
But
yes.
the idea of this series was really to specifically think about the impact of AI on the global telecom business, right? And sort of your particular section of that is cloud. We've talked to Alan already about connecting those clouds, the underlying transport sort of business. But I want us today to just think through, you know, sort of on cloud exactly what AI does that's different. And so that's where I was thinking through in this episode. A lot of these conversations have been something along the lines of like AI hasn't yet sort of radically changed the way that we think about the telecom world. It has sort of strengthened maybe certain trends that were already underway. The move to cloud has been, you know, going for 15 years, right? You know what I mean? So
Hmm.
and the effect that cloud in and of itself, and the differences in the way that enterprises consume compute and software services, like AI kind of like it's going to change those things, but it sort of deepens some of those trends, right? I mean, it's
Right.
not yet made us totally rethink the network.
Right. No, not at all. And in fact, when we're talking about cloud, we're often, or AI, we're often talking about GPU as a service or GPU compute. And this has been a service of all the hyperscalers for a long time. It's
Hmm.
only just recently with basically with ChatGPT, the release of ChatGPT, end of 2022, where
Hmm.
we
Hmm.
see kind of everything blow up or explode.
Right.
So where we see the shift from GPU as a service being handled, demand being handled by the hyperscalers, to post 2022 or the end of 2022 with ChatGPT, we see demand overwhelming the hyperscalers. So
Hmm.
then you see the shift to they needed for overflow different providers of GPU service like CoreWeave
Right.
to help out to handle the demand until they could build their own data centers or their own AI focused data centers or to meet this demand. And of course, building out hyperscaler regions or data centers is not a fast task, something that could be done quickly. This will happen over many years, two to 4 years.
I'm going to probably talk a
5.
lot more about that with Jon Hjembo, our colleague who tracks the data centers. But I think that's a really interesting point that heavy infrastructure just does not move at the speed of software, right? So,
Right,
yeah.
right. So this is where you see all these neo clouds or GPU as a service providers popping up and getting a lot of investment and a lot of focus on them. Is they're basically helping supply you know the hyperscalers that have too much demand for existing infrastructure and existing computer services. So this is where we see the blossom of these neo clouds.
So let me ask you this, because one of the things that we have to think about at TeleGeography, just part of our job, is how to operationalize these new things that come along. So just give us a little background for folks who may never have looked at our Cloud WAN product, for example, of what we were tracking and then what we added with the GPU as a service kind of neo cloud to that recently.
What? You don't know CW? No. Yes. We
I
track.
do.
Yeah, yeah. Okay,
Yeah.
good start.
Yeah.
We track cloud infrastructure. So cloud
Mhm.
infrastructure, what we look at are the regions themselves, um, the larger regions, but also now the local zones, which are kind of small regions associated or connected to the larger regions. We look at on ramps getting onto the cloud networks. We also look at CDNs, and then we look at locations like co-locations or areas where you have the cloud providers interconnecting with a carrier or network service provider and a data center all in one spot. So
Mm-hmm.
this is what we track. And what we've done historically is just tracked the hyperscalers, because there's
Right.
been a lot of small scale cloud providers since the beginning. But what we've really tracked is the hyperscalers, because the hyperscalers basically are the companies and the infrastructures that are kind of changing the game in different markets.
Right.
So once a hyperscaler goes in, the ecosystem completely changes, meaning it explodes. Maybe prices drop, data centers are built, and then more ISPs
Networks have to
connect.
react, right? Yeah.
Exactly,
Yeah.
exactly.
Mm-hmm.
So this is why the main reason we've been focusing just on the hyperscalers and not the other cloud providers. And we also look at, when we talk about cloud services, telegeography, we're looking at infrastructure as a service. So the infrastructure as services, not the software as a service and the platform as a
Mm-hmm. Mm-hmm.
service. So
Right.
just
I mean, SaaS doesn't have the same physical infrastructure and network issues that would go along with the more infrastructure and platform as a service kind of data center
correct.
oriented things, right? Yeah.
Correct.
Yeah.
But some of the SaaS providers actually evolve into
Right. Well, and they
cloud provider
utilize those
infrastructure as service.
hyperscalers, right, to
Exactly.
serve their customers, right? And I
Exactly.
was saying to Alan when we were talking, because
Mm-hmm.
of course all these things are closely tied together,
Uh-huh.
that one of my favorite charts that you produce in CW is this map that has a slider that goes from, I think it's 2006, maybe 2008, whatever it
Yep.
is, up
2006.
to the
Uh-huh.
present, right? And
Mm-hmm.
shows the last 20 years then of cloud on ramp development. And that's just a really fascinating story, right?
Yep.
That you go from a few instances, mostly in North America, right, to
Yep.
this expanding all around the world, right? So, does
And
AI increase the need for that, or I mean, it's really just
yes.
like that
Yep.
same kind of idea of like it's the same trend that's been going, but it's just more, right?
Yeah. Well, I'll take a step back and just talk about how we shifted gears from just hyperscalers first, and
Yes, please, yeah,
this kind
yeah.
of leads to that, to answering the
Hmm.
question you just asked. But um, what we found recently in the last couple of years, and I'll talk about this a little bit more a little bit later, but is if you just look at the cloud infrastructure, we've seen over the last couple of years a slowdown or a decrease in the
Right.
launches of new regions. And at first, we were unsure. This is about 3 years ago, and then, of course, with what's happening with AI, with the GPUs as a service, and with all the investment, et cetera, we started tracking the large ones as well, large GPUs as a service. When I talk about GPUs as a service, we're talking about the kind of GPU compute only or primarily like AI factory style providers. And what we track is actually the GPU as a service providers that have some type of cloud offering to access the GPU services, GPU as a service services. So there are some GPU as a service providers that use, for example, the hyperscalers as the
Right.
platform to
Right.
access. But what we're looking at, what we track primarily is the kind of almost pure play GPU as a service.
Right. When there's vertical integration, when they are providing the
Correct.
actual infrastructure. Right. Yeah. Yeah.
Exactly.
Which is
But
what's new in the market, sort of
correct.
everyone has used
Correct.
hyperscalers for all kinds of things. And so that's
Yep.
just, right. Yeah.
Right. And the plus of using GPU as a service provider, cloud provider, is you're kind of just accessing one service. The hypervisor is gone. It's the GPU works as a service. It works better. The compute is faster, more efficient, etc., less expensive. So this is one of the reasons pushing demand or pushing customers to GPU as a service providers. But
What
I
about,
want to add.
yes, please. Yeah. Keep
I was
going.
just going
I don't
to
want to
add one
derail
more
you.
thing
Yeah.
to that, because
Yeah.
we do follow that GPU as a service providers, but we also are following another group of providers that are kind of the distributed cloud providers. They're important too, and we'll talk a little bit about that in a sec. But these are companies that maybe don't have the money to invest in the GPU, servers themselves or the chips
Right.
themselves, but they do offer, for example, maybe inference, or they're providing kind of a network to access the GPUs as service providers as well. So these two groups are new to CW. Distributed cloud, which have historically are the major CDNs,
Right.
and there are other players as well. So, but back to the GPUs as service providers. Wait, let's go back to your question. What was your question? Oh, how it changed?
Yeah, my question was really ultimately about geography, right?
Yep.
It's because I think that's the core of what makes CW really interesting to me anyway, and I think to a lot of users, right, is thinking through, how the centers of geography are constantly changing. And I think now really interesting to look at how inferencing in particular, right? Because, training going to happen in places like Ashburn, Frankfurt, whatever, right? But
Right.
inferencing less so. And the whole GPU as a service neocloud thing has some need to be closer to the user. And of course, the reason I brought up that map is that the whole history of the cloud market has been moving away from the Ashburn being the center of gravity of everything, right? So I'm just curious on the geographic expansion of all of these and how that might be an AI impact, if you will.
Yep. But for the GPUs as a service providers, like kind of the pure play neo clouds, they'll be set up very similarly to the hyperscalers, because a lot of the GPUs as a service or the neo clouds are not necessarily often are not. They're the old crypto miners that most of these companies were crypto miners
Fascinating. Yeah, that is.
originally.
I did not know that. That is really
Yeah,
interesting.
yeah.
Yeah,
Okay, then
it
we'll
makes a
jump
lot of
into
sense,
we'll
actually.
dive into this a little bit.
Yeah.
Yeah, as the crypto mining became less and less profitable, or you see a lot of the companies pivoting to AI, especially late around 2018,
Yeah. Yeah.
2019. Yeah,
Yeah.
it's a little bit early for that. Now,
Yeah.
2018, 2019, like CoreWeave, of course, is
hmm
the big
hmm
example. And a lot of these crypto miners weren't building their data centers close to population centers. They were going where it was super cheap, usually near energy source, because the crypto mining needed lots of power and
Right.
lots of cooling. So they built in often very far away places, maybe in the north or in Iceland or Canada, etc.
Hmm.
So they were not built to kind of with this idea in mind of connecting to population centers.
Right.
Okay. But then when they pivoted to AI, this will change a bit. And this is actually a problem, maybe a midterm problem for these companies because the data centers aren't nearby
Right.
population centers. So they need to build the networks that connect their data centers back to population centers.
Hmm.
So this is one area where we see a lot of activity. And as you look forward, what's going to happen? This is where there's a lot of activity and kind of question marks and how fast this is going to grow, et cetera. But to go back to geography, that's one part of the geography. Another part of geography is they're actually very similar to the hyperscalers in the sense that hyperscalers at first, like you said, only built out in kind of low hanging fruit areas, meaning
Right.
cheap land, well connected, low prices for transport, things like this. So where is that? That's the very developed markets. That's North America, specifically U.S., maybe Canada, and Western Europe, and parts of East Asia. So
Hmm.
with GPU as a service, what's happening? They're building out a lot of these data centers, or have built out in these same areas. So if you look at a map of where, kind of the map that we have for hyperscalers, if you look for GPU as a service providers now, the neoclouds, they're primarily in US, Canada, and
Hmm.
Western Europe. And not as much, actually, in Asia. That's the surprising part. There are some, but it's not as dense and
Hmm.
just as many as you see in North America or U.S. and Canada and Western Europe.
But that there's a recursive relationship here, right? Because AI adoption is going to be best where your latency and all that sort of work with you. Um, at the same time, right? So in other words, like the presence of the neo clouds will foster AI adoption, right? You know what I mean?
Uh-huh.
But at the same time, if they build, people will use it more, right? You know what I mean?
Right.
So there's
Right.
that like the neo clouds need to be where people are already adopting AI and are more ready for that, but they also need to move to areas where people have not yet adopted AI, and that will help them adopt AI, right? So,
Right.
um,
Right. And yeah, and I would say that this, since most of the kind of more well known or the more developed GPU service providers, the neoclouds, were crypto miners or something similar.
mhm.
They aren't built out, yeah, near
Yeah,
population
because
centers.
there's no
So
need to develop crypto, and there's no latency, there's no geographic sensitivity there, right? So, yeah.
right. So now the data centers are built, but now they're focusing on how to kind of distribute this. And this is where you see, and this is actually why we also track the distributed cloud, because a lot of these distributed
Hmm.
cloud providers are really AI platforms, cloud platforms that are can be inference, like
Right.
inference only. They're not looking at training, but they're kind of filling the gap of connecting maybe these data centers that are in faraway places to population centers. So the
Well, let me.
CDN. Uh-huh.
Yeah, I was going to say, let me back you up there and say,
Sure.
okay, so if we have the neo clouds having this kind of legacy of cryptocurrency farming, and the distributed clouds have tell us about their legacy and why CDN infrastructure was sort of poised to do this, and also why CDN infrastructure wasn't doing what it originally did. Isn't that a sort of coincidence, right? You know that
Yeah,
the CDN market
completely.
was already kind of waning in
Yes.
terms of the demand for it, but then there's this new opportunity, right? So.
Right, right. It's kind of well known over the last couple of years that CDN services or CDN companies are not super super profitable just on the content
The
distribution side.
core, right, the core
Right,
mission of a CDN, which is
right,
to cache data locally to users because the hyperscalers do that themselves now, right? So like,
right. It's more now on the security side,
mhm,
um, possibly live streaming, but that has a lot of problems too. Streaming, having a network stream ready is very high cost, etc. So it's
mhm,
kind of a wash in how profitable that can be,
right,
and it has to be ready and always on. So you see some cloud companies, or I'm sorry, CDN companies, kind of branching into cloud services, cloud compute, because
mhm,
they have this great network that's very
right,
highly distributed. And I think, and they do offer some cloud compute, like with Akamai acquisition of Linode.
right,
Um, we've seen movement in this area, but they still don't have the compute to the level of a hyperscaler or a GPU's, a neo cloud that is only focused on GPU compute. They do have to offer GPU compute, but not at the same
mhm,
kind of
mhm,
level as a pure play kind of pure play GPUs as service provider. So AI is great for them because
mhm,
this they can look at building out their or using their existing networks or platforms as AI inference platforms,
right,
and so they kind of fill this gap or this need of the pure play GPUs as service providers connecting to kind of the wider network. So a lot of these GPUs as service providers, even the ones that have their own cloud platforms, they have no or very little network themselves.
mhm,
If you
mhm.
go peering database, check out any of these. Very few of them peer anywhere, or so this is kind of new. And a lot of them have their background in crypto mining. So this is not something they thought about before. So
Do you
it's
think that will change, or I mean, it's the network is there; it's easy enough to utilize someone else's network, right? So,
well, true, but some of these places that they built are not necessarily connected to
right, right, the network is
networks.
not there, right? Yeah,
Exactly.
exactly. Yeah,
The network is
yeah,
not there like in places in Canada where they were searching for cheap energy or power
right,
sources.
right,
So they got that, but the problem, the flip side of that is that they're far away from population centers and they have very
right,
little connectivity. So this is what you see right now. Everybody building out, or the bigger ones, the ones that are kind of the core weaves that are kind of ahead of the game, or at least leading the pack in investment, building out network, etc. This is what they're doing right now: is building out
right.
their network.
It's funny how there's nothing new under the sun. Because if I had had a conversation related to this like 15 plus years ago, it might have been about when the hyperscalers were first starting to expand into different regions. They had not originally really thought about, well, which submarine cables am I close to, and right, you know what I mean. So
Right, right.
it seems like the this new story is really the old story of data center location doesn't really take the network into account until it's already done, right? So,
Right,
yeah,
right. That's
there are
true. And
exceptions, obviously. Lots of
yeah,
people have learned this lesson, but it's interesting to hear that that's still an issue.
yep, yep. No, definitely. And yeah, like I said, crypto mining, there was no need to have,
Right.
a couple 100G waves connecting your data center to, you know,
And
the larger
I think
networks.
that actually like I think raises a really interesting point about AI and something that we don't know yet, which is that I talk to a lot of people about this topic, right? And some of them on even the more software development, AI development side. And it seems to me to be still pretty unclear to everyone that I talk to of what AI actually ends up looking like. Is it just sort of more souped up versions of what we currently have, LLMs, that sort of thing? Is it something different? All of that, like how that shakes out, really does impact cloud geography, distributed cloud geography, neo cloud geography, because Bitcoin coin mining is I should say crypto mining, right? Is a
Uh,
great example in the sense that this really compute intense sort of thing that the location at really doesn't matter, right? There
right.
very well could be some AI apps that we, or whatever you want to call that. I don't even know if apps is the right word anymore, but some AI use cases that are not latency sensitive at all, right?
Right.
It could be that most of them end up being incredibly latency sensitive. We really kind of don't know the answer to that yet,
But I mean, if we just look at existing cloud services, there's
Mm-hmm.
the whole range, and there's a lot of cloud
Exactly.
services that are not latency sensitive.
Yeah.
So, that's why you can serve North Africa or Central Africa out of Europe, you know.
Right. Mm-hmm.
So
So more of the same is what you're saying yet again there, right? Yeah, yeah, yeah.
exactly. There
Mm-hmm.
will be AI that you need that will be latency sensitive. That this will be an issue, and there will be other services that you don't need. Latency isn't an issue, and you see this now because what we talk about a lot is on the training side, because that's where you see the immense amount of
Massive
traffic.
demand, right?
Right,
Yeah.
massive traffic, massive demand, but so far, this is only within the data center itself,
Mm-hmm.
or maybe in
Between big
the
data center.
metro, or
Yeah. Mm-hmm.
within a metro.
Right.
It's maybe you see a little bit of kind of uh, region within a region, multiple locations, like
Mm-hmm.
within a
Mm-hmm.
country, but it's we don't see training traffic between, for example, North America and South
Right.
America, etc.
I think that's a really good point, because I think this point has actually been lost in the fray of like thinking about, like the massive data demands are when you're training, when you have a data lake, and when you're trying to, once the model is done, so to speak,
Right,
there's not like a difficulty of getting it distributed around the world. It's the
right,
creating the model. And so
right.
that's not, so when we think about, submarine cable demand has gotten like, you know what I mean?
Yeah.
Like
Well,
it's mostly about the metro, right? So yeah.
that's true, but at the same time, if you think about peering, and I'll
Hmm.
use the Africa example because I work mostly in Africa, and it's, I think, a good analogy. That when we talked about peering, and we said, "Wow, all the traffic is going to be local, so it's going to kill all the interregional."
That was not the case, right? Yeah.
Right, because
Yeah.
demand was so high once, for example, internet started working locally,
Hmm.
caching,
Hmm.
that they needed more content to
Right.
cache. Even if they
Yeah.
had local content, they still needed more from, say, for example, Europe to Africa. So
Yeah, absolutely.
instead of killing localizing everything and killing the long haul, it actually was encouraging or stimulated demand. So
Right.
I could see that happening now. At this point in time, what we've seen more is within regions, a
Hmm.
ton of traffic, or more localized traffic, but not just within a metro. But we're seeing like increased traffic within a region, or for example, hyperscalers or cloud providers, when they talk about where their traffic is, it's usually within regions, not between the regions, like we just
Right.
said.
Right.
But as it grows within the regions,
That means more demand growth between regions. Right. Exactly.
exactly, it won't be
Yeah.
growing
Yeah.
at the
Yeah.
same rate as within the region, but
Right.
it's still
Right.
growing very, very strongly. So,
Absolutely. Yeah. Yeah. And so it's like, to be clear, what I meant was in the sense of like that long haul demand isn't training. It's
right.
the knock on effect of the training. Right. So
Mm,
I think it's good to be careful about that language, that like where the training is bolstering demand is
right.
within the metro. On the long haul, not to say that there won't be an increase in, there was always an increase in demand, right?
Right.
There
Right.
may be even more of an increase in demand, obviously, on these long haul routes as a result of this, but not because you're like training models across the globe per se, right?
Right.
So, yeah,
Right.
interesting.
And
All right,
yeah.
so Patrick, I'm gonna make you do two things. I'm gonna make you think about, you'll update CW in the fall, right?
Uh-huh.
Uh, what are you looking to understand better then, and then let's think about like further out, just beyond necessarily what we do. But let's start with CW. Like
Uh-huh.
what like, so for the rest of 2026, in the very near term, to make it a little bit more digestible, as you go to update the kind of things that we track in CW? What are you looking for? What are you expecting to see?
Well, until like very recently, like as in just this last year, one reason we didn't track the GPUs as service providers and distributed cloud, well, distributed cloud a little bit more, but GPUs as service providers, the neo clouds, is because they were still very small and
Hmm.
they didn't uh, publish or reveal
Hmm.
where their data centers were or anything. And now
Hmm.
they're realizing that
That
they're kind
benefits
of
them.
right. It
Yeah.
benefits them, and they're
Yeah.
modeling more off of the hyperscalers. So
Right.
now, if you look at CoreWeave's kind of, if you check out their website and compare it, it's starting to look more and more like an AWS or
Interesting.
Google Cloud,
Very interesting.
etc.
Yeah.
So now, and everything is happening now because the investing is coming in and investments coming in, and they're building out their networks quickly. There's a whole bunch of new data that's like popping up like weekly, monthly. So
Hmm.
right now we're just trying to get all the data collected.
That's
So
awesome. That's a great position to be in as an analyst, right?
right,
So,
right,
yeah.
and uh, also for the so that's one part of it, but you also have to go back to what we were saying is what these neo clouds are doing is they're the overflow for the hyperscalers.
Hmm.
Hyperscalers are have their own chips.
I was going
It's
to say
not
they're
just
not going to give
NVIDIA.
away any market that they don't have to, right? So yeah.
Right, right. And as they build out their kind of AI focused data centers using their own chips, then there'll be less overflow for these
Hmm.
others like CoreWeave, etc. So then what's going to happen? Are they NVIDIA shifts in giving kind of its newest, best chips to the core weaves to keep because
Hmm.
they realize that Google and AWS and Azure have their own chips. So
Hmm.
eventually, they probably won't be as big of
Right.
customers.
Right.
So it'll be interesting these next couple of years as the AI kind of factories or hyperscaler AI data centers start coming online. What will happen?
Hmm. Hmm.
Will there be more customers for the GPUs service providers, the neo clouds, because they're cheaper, a little bit more efficient, or will they go back to the hyperscalers, or what will happen? What will happen there? This is one thing we're looking at over the next 2 or 3 years. We'll see what happens.
Yeah, I think that's really interesting, and it is clear from past experience, right, that it is hard to see how these markets will develop in terms of what the optimal geographic distribution is, what the optimal scale is, right? All these kinds of things, especially because, and this is where I'm going to talk to Jon Hjembo, so not to
Uh-huh.
have you respond to this other than you know what I mean, like
Yeah, yeah.
related to what you do specifically here,
Right,
but
right,
that all of this is tied to heavy infrastructure that is difficult to develop, that there are only so many people
right,
with skills and all of that, right? You know what I mean? So I think I
right,
always want in this entire series to bring people back to the ground reality, that the development of AI isn't uniquely about what we can do with AI from a software and human interaction perspective. It's about how much it costs to put AI where it needs to be to do these things and to move the bits around the world and whatnot, right? So
right. And going back to a point we made earlier about it seemed on the cloud side that everything was slowing down the last 2 years, 3 years,
right, yes.
because that was the shift to AI. So we're like, why? Why are
Ah,
there so few? Because there are only 14 data center launches in 2024 versus like 30 a
right,
couple of years
right.
earlier. So
Hmm.
it was back to levels like 10 years ago when they first started. So
Hmm.
it's this is where we actually see the investment shifting, and we see, for example, in Africa, because I'm there a lot, we saw investment that was starting to come into Africa. All of a sudden
Hmm.
everything was put on hold, slowed down, and or at a much smaller
Very interesting.
scale.
Yeah.
So that was all the shift to uh, regionally back to US and Europe to
Because
focus
there's
on
only
building out
so
these
many
AIs.
chips. There's only so much fiber being manufactured. There's, you know what I mean? So exactly, yeah,
Right,
that
right.
is really interesting. So,
Yep, yep.
yeah, and so there again, how there's these unpredictable growth curves for each segment of the market based on ultimately, like, I think what's really going to drive all of this, like, like maybe there'll be some consumer things that I can't imagine, and that's really possible. But it seems to me that, like, what does AI actually do for the enterprise is a lot of what's going to drive this. And I think we're very much in that, like, we're unsure stage, like right
Discovery.
now.
Yeah,
Yeah, exactly. Like,
yeah.
not to get too deep into this aspect of it, but that you see stories every day now about, because you and I both have to read the tech news every day, right?
Uh,
Oh, enterprise, CFOs are realizing that they're paying way more for their tokens than they thought they were. And then, or on the other end of things, when you have an all you can eat kind of AI sort of, the AI companies are realizing that they're paying a lot more per token and their overhead
right.
costs than they thought they were, and all these things. So I think so much is going to come down to that ROI on the enterprise end of what are we really getting out of this? How much
Right.
does it really cost? And that's where the telecom world is going to have to respond, right?
Yeah, and I mean, it's going to be like cloud, like, oh, everything in the cloud. Oh, wait, no, let's shift back to
Exactly,
on-premise.
exactly.
Oh, no, okay,
Yeah,
somewhere hybrid, somewhere in between.
right.
It's going to be, I think, the same thing for
I
AI.
mean, that's almost always the answer, right? It's so
Right.
you don't
Yeah,
listen
yeah.
to the people who are, going to say everything's going to be this way. No, everything's going to be that way. It's usually
Right.
like something that is somewhere in the middle. I mean, sort of depends
Right.
on what you mean by that, of course, but
Right.
I very much see the early internet as a key example of this, right? That no one was quite sure exactly how to utilize it as an enterprise, for example. That didn't mean that like I'm sure you remember, like, goofballs from the late '90s, like writing articles, think pieces about how the internet was a silly fad. You know what I
Yeah,
mean?
yeah.
Like,
It'll blow over in a few
yeah,
years. Yeah,
exactly.
yeah,
Yeah,
yeah.
you know what I mean?
Yeah.
Or that, like, oh, this is we're going to solve every problem in the world, and the whole economy is going to be nothing but, so
Yeah, yeah.
it always
AI.
tends to, yeah, exactly, it always tends to
Yeah.
be that we find some kind of, like, middle path. That seems probable here. We'll see.
Right, right. Yeah, so for the short term, I'd say, yeah, that's what we're just trying to keep up with all the new data that's coming out and all the new regions that are coming online, because I think over the next couple of years you're going to see a lot. But further out, I think it's going to be the networks connecting the data centers over the next few
Yeah.
years, because just to see right now, because kind of what I'm hearing is it's hard to get all this capacity, which I was kind of surprised about. But I am hearing stories like at ITW, people were talking
Hmm.
about this as well. Um,
Yeah, well, it's interesting that you say that, because to wrap things up, I'm surprised and I'm not surprised by that, because again, it's always all about scale and geography, right? You know what
uh-huh,
I mean? So there, it's surprising in the sense that, like, okay, well, when you're talking terrestrial, you can put in thousands of fiber pairs. Each fiber pair has a huge amount of potential capacity, especially with
uh-huh,
modern fiber, and, like, but it's also like, again, if what you're trying to do is figure out, like, what's the best place to put this megawatt data center, it's near this power plant where land is cheap or whatever,
right,
then of course it is really hard to get network there.
right,
Especially, it's really hard to get competitive network there.
right.
There's some real premium opportunity for network providers that can
Yes,
do that rollout, and be one. But nobody wants only one network provider because that's a
right.
massive liability, right? So
Exactly,
yeah, so
exactly.
so I think it's both and always, right? It's like
Right,
there are situations where there's already just a massive glut of capacity, but
right,
there's also plenty of situations where we need to go back to that old, oh, the network has to chase what's going on in the compute world, right? So
yep, I believe. And then, I mean, something we're not going to cover, but or we touched very lightly on, that John will have to talk about a lot,
right,
of course, is power. I mean,
yeah,
that's
exactly, yeah,
the that's the one of the big
Well,
challenges.
and to that point, again, to sort of wrap us up, like power is a network too, right?
Yeah,
It's
right,
it is
exactly.
conceptually very similar, except for they have a lot more vertical integration and
Yeah,
monopolies than we do in networks, but it's still physical wires that have to connect to each other, right? So
yep,
I think that that there's a lot to remind people of, again, even in the industry, about how all of this has to actually work for it to play out to what we're hearing about, right? So
right,
that's what we're here
exactly.
for. Yeah.
Yeah, that's the
Awesome,
fun.
Patrick. Well, yeah, thank you so
Okay,
much for taking time late in your day there in
sure.
Paris.
It's
And
fun talk.
yeah, let's catch up again soon.
Okay, we will.
All right.
Okay, man.
Cheers.
Thanks a lot. Bye.
Yeah. Okay, coming up next, we'll have Jon Hjembo to tell us all about that final infrastructure layer of the actual data centers themselves. Welcome back onto the show, Jon.
Hey, thanks, Greg. Good to be here.
Yeah, so you were here, so to speak, just a mere 6 months ago or so. But just for anybody who's dipping into this episode and this series, if you could remind us both kind of what specifically you do at TeleGeography, and I know you wear many hats, so we'll focus on the data center side. But then I also want to hear from you specifically, very high level, of course, what kind of metrics we actually cover in the data center product.
Yeah, sure. So I lead and maintain our data center research database for our customers, and work with a number of our teammates and some supplementary help in the summer to update vast amounts of information that go into those databases. But what we track across the board is data center capacity development by metropolitan market
Mm-hmm.
for markets all around the world. That's looking at gross space, fitted colocation or raised floor space, or however you want to term that, IT space, um, megawatts to the building. So we look at capacity on a number of different levels, and then we look at connectivity very heavily, given our focus at telegeography being networks above all.
Mm-hmm.
That's just the major tie-in to the data center market. The data centers are where we go to interconnect and make the internet happen. So we gather all kinds of information on connectivity as well, cloud on ramps, IX presence, and carrier presence as well. So
Is
those are the
very
main
well
things.
put. Yeah, yeah, exactly. And to tie it in, this whole series I've been doing mostly with folks from various positions in the industry has been about the impact on the networks of this AI revolution, if you will, that we're undergoing. But in our capstone here, I've talked to our colleagues Patrick about kind of like the cloud layer that happens on top of the data centers, if you will, and I talked to Alan about
Yeah.
connecting those data centers and the various issues there. So I wanted to wrap it up by talking to you to really think about that absolutely physical layer of the actual data centers themselves and what's going on there. So I want to start out talking inevitably, as we have to, about booms and bottlenecks, right?
Yeah.
Many people in the IT world in general, even in the telecom world, if you will, can forget how much AI is really a physical infrastructure product, not just a software product. You do not forget that, right? So
Right.
what are we
No,
seeing
no,
in terms of data
not at
center
all.
development for AI specifically, and what pain points have emerged?
Yeah. So a couple of things about that. I'd say leading into the end of last year, we were seeing an absolute frenzy in the amount of announcements that were coming out about like gigawatt campuses left, right, and everywhere. Um, it seemed like it died down over the turnover to the new year,
They hit a
but it's
reality
starting to.
wall. Yeah,
That's what
yeah,
I thought, but then it
yeah.
started to sort of ramp up again. So we're starting to see
Interesting.
more of those
Very
announcements.
interesting. Yeah.
Yeah, but it's now more mixed, I would say.
Hmm.
There's a combination of kind of troubling signs and still further announcements.
Hmm.
But it was like all pure optimism, I'd say, going into the end of the year. There
Right.
was kind of a lull in the action, and now it's kind of a mix of new announcements and hesitation. So it's been weird. And to kind of tie it into how we're tracking it at TeleGeography, when we see these announcements coming up, we're not quick to publish them. We will kind
Mm-hmm.
of make note of them in the back end of the databases and then see what happens, and then
Right.
sort of project what we think is actually going to happen on in a timely manner. On a campus level, building by building, if we can, as best we can, and some things don't pan out as expected. But
Hmm.
to give you a snapshot view of where we are right now, um, in terms of what we think will be deployed, we've seen an uptick of more than 35% of sites in the pipeline just between 2024 and 2025. So just
Wow.
leading into that period, 35% increase in what was announced, what was coming into the pipeline. So
And to
that
be
doesn't
clear,
even
that's over
that
a
doesn't
data center
include.
market that's already huge, right? So
It
35%
is.
is
Well, no,
massive,
I'm
right?
sorry.
Yeah.
I'm sorry. Not 35% of growth in the overall market, but 35%
Ah,
more sites in the pipeline than had been in the pipeline
I
before.
see. Okay,
Right?
that's
So
still
yeah,
big, but not. I was
still
like,
big, but
holy cow, right? Yeah,
not nearly as
yeah.
insane.
Okay,
Yes,
yeah,
yeah.
yeah.
But that doesn't include all the hype that we're hearing. There's a lot that
Hmm.
we're just kind of like, let's see how this pans out.
Right.
And to give one example one good example, I think a really prime example of how the hype train is starting to show signs of weakness. The flagship Stargate Abilene campus that OpenAI and Oracle announced, this was going to be a gigawatt plus development in West Texas, and they're already running 300 megawatts now. But it was announced that they were starting to look for other tenants to further expand there because they couldn't justify the level of expansion they had initially announced,
Mm-hmm.
given new projections in their demand. So
Right.
that's one example, but it is just one of a number of examples, and so
So
that's
yeah.
been weird. This combination of actual surge in development, um, even higher hype in terms of what's been announced, and kind of a throttling back in
Hmm.
some level, as well as in terms of expectations.
Well, yeah, I want to ask you about this. It made me think that it seemed like what you're suggesting there is that the pulling back in that particular case was due to potentially insufficient demand. I would have thought that a lot of the pulling back just had to do with lack of supply, right? Like in terms of this skilled labor, the materials that because of this boom, I would have thought that's the chief bottleneck. But I guess it's kind of we're seeing
No,
also some demand problems as well.
yeah, I think there, at least internally, and that may vary by individual company and
Of
by
course, yeah. Hmm.
their individual modeling for what they're projecting. Others might not see it that way, but
Right.
at least in the case of OpenAI and Oracle, that was the issue they faced.
Hmm.
Another thing I would say in terms of like bottlenecks, so other than the overall kind of like surge in announcements and whatever, um, another big bottleneck issue is just continuing evolving regulatory changes. There's still a lot kind of that's in flux there in terms of how individual countries are handling AI development, data centers overall, but some of them are really like hyper focused specifically on AI. So look at Malaysia, for example. They're not approving AI projects specifically now due to water and power constraints for at least 2 years while they kind of reevaluate what's happening there. That's huge. I mean, because this is a primary spillover location where you already can't develop new stuff in Singapore. So inevitably stuff pushes across the border to Johor Bahru and then even into the Cyberjaya and KL markets. And as that's happening, the reality has caught up to Malaysia as well. The reality is catching up everywhere. So in Brazil, there was a lot of positivity, a lot of expectation around um, uh, high levels of growth in the data center market and AI specifically going into Brazil, as last year they were looking to establish uh, to do away with regulations that impose tariffs on telecom equipment importation. That had been a major blockage to new data center development, were these high import tariffs. So it was announced that they were going to do away with that. But there's still been some regulatory shakiness after those initial announcements. And there's an AI Act on the horizon that's being worked out that could actually increase the cost of training in Brazil. So it's still unsure as to how favorable that environment's going to be ultimately, because even in a country with such abundant power, that you still have, like everywhere else in the world, everybody knows what data centers are right now, and so as politicians are seeking re-election in Brazil, they're trying to figure out the balance between, like, we want to do away with these tariffs and we want to make things as easy as possible for data centers to deploy here, and when they know that their constituents are saying, not in my backyard, right? So that's an issue there. Ireland has laid out new regulations that things had completely shut down, especially in the Dublin area, for years, while Iregrid basically said we're not going to hook up any new data centers at all. And now the stipulation in place is that any site that's over 10 megavolt amps has to deliver power equivalent to what they demand. They have to deliver their own power. So that has started the ball rolling there, but that's an example of, we're still getting regulatory clarity, some 6-7 years after things kind of ground to a halt there. And then in the US, of course, there's federal pressure to push hyperscale data center developers to provide their own behind the grid power generation. And which is already becoming a big trend. So there's a lot happening on the regulatory side too that's really contributing to this.
And then, I would add to that the regulatory side in this case, along with network development, by the way, is multifaceted, especially in the US, is certainly true in other countries as well, where there are federal, state, and municipal regulations that apply.
No question about it.
Yeah.
No question about it. And I mean, we've heard that in some places, that's actually a major headache especially when you have overlapping jurisdictions with conflicting regulations. That's been an issue for folks as well. I was just going to say the other really big thing, of course, when it comes to bottlenecks, is just what we're going to do long term in terms of power, and that's the biggest thing. So right now, when operators are looking to figure out what they're going to do going forward, the long-term solution seems to be pushing towards small modular reactors, but that we're still looking at 2030 plus for viable commercial deployment. That's way far out, considering how frantic people are to
way
find
far out
power now. That's like 4 whole years away. Who can wait that long? So in the meantime, this behind the meter trend is getting big, and a lot of that is through gas conversion, using mini gen solutions. These are really expensive, but that's what people are doing because it's what's available. And it's only available some places. You got to go to zones where you can access the gas pipeline in order to pull that off. Fuel cells are becoming more of a thing, at least for smaller loads, similar to batteries, except that they're actually generating power within those cells, using hydrogen in liquid form or from natural gas or other sources to generate power on a small scale locally. So there's these like interim solutions and then long-term solutions to try to figure this bottleneck out. But it's a major. But yeah, there are multiple issues that everyone's wrestling with for sure. So it's a wild time.
It's funny because this reminds me that this is like a long-standing kind of joke among us analysts at TeleGeography. Folks might remember this book from like, I don't know, 20 some years ago by Thomas Friedman, the world is flat.
Yeah,
Our
yeah,
entire careers is showing how the world is not flat and it's not going to be flat. He makes some
yeah,
other points, whatever. I'm not going to, you know what I mean? But yeah, it's like, it's not flat, right? You know what I
yeah.
mean? Like,
No question.
that the physical geography, the different regulatory environments, the competitive landscapes for all of these things differ all across the world. There's no like one thing you can say about this market, um, other than perhaps power and water are probably fairly difficult everywhere, but the degrees of difficulty
Yeah.
certainly vary, right? So yeah.
Yes. No, absolutely.
So tying it into geography as we always do, right? This is
Yeah.
funny because like people will say this, but this is like literally true. Yesterday at dinner, my son brought up that one of his like classmates was talking about how Northern Virginia is the biggest internet market in the world. It's like, well, as it happens,
Yes.
I'm a world class expert on this
70.
topic, right? Because I live in Loudoun County, and I find it interesting that despite whatever exaggerations are the case about Loudoun County, it is still the case that
What,
Northern Virginia
whatever
is
70% of the world's
right.
internet
Yeah,
exaggerations,
exactly right.
Yeah.
However much that exaggeration isn't true, it is still the case that Northern Virginia is the top data center market. But
Yeah,
there's still
it
growth
is.
here, so I want to focus
Yeah.
on that. Like in other core markets too, we're still seeing
Yeah.
growth in core markets. Talk a little bit about that.
Yeah, it is. It's true. It's weird. So there's this varies a lot by individual operator and how they've planned ahead. I've found, and there's a lot I don't know about this, but um, those who didn't anticipate their needs fast enough have kind of ground to a halt, but those who
Mm-hmm.
had prepared well in advance are able to still build going, even now after the start of,
Right, and by
the
that you mean
problems
like they
with new
had long-term
transmission power.
planning of we need this
They
land, we
already
need
had
this
power.
power allocation, right?
They already had power allocated before it was announced, a couple of years ago that there was no more power to be had for data
Right.
centers until new transmission lines were developed. So some operators still have available power that was reserved before that happened, and so they're still building. Others are not so fortunate. So, but yeah, I mean, core markets are still growing, absolutely, or at least have things being built ready to come online once power becomes available.
Right. We
So
would see that
Northern
as
Virginia,
growth even if it
there's
had been
that,
planned for years, right? Yeah.
right? So Northern Virginia still has something like we estimate around 3.6 million square feet coming in the near pipeline. So that's still
Wow.
a lot.
Yeah.
So and some of that is has power already allocated. In some cases, operators may be deploying their own power solutions. I mean, I've heard there are cases where weird things are happening that aren't necessarily, approved in terms of how they're accessing certain types of power. And so, people are finding workarounds, any way they can. So there's still development happening. Um, yeah, and it's not just Northern Virginia. Lots of core markets are still have a lot in the pipeline. In Europe, I kind of marvel that and it really does vary. I mean, some markets have kind of shut down, and
Mm-hmm.
others have not. In Germany, where there's been a lot of tightening regulation, there's still tons coming into Frankfurt and Berlin, in
Mm-hmm.
particular, but other places too. So, and again, some of that is announced, some of it is being built but waiting on power. Some of that has power allocated. So
Right.
yeah,
Interesting. And so a long-standing point of confusion in the industry has been among many other terms. But when people use the word edge, right,
yeah,
that could mean anything that's like outside of the core markets down to like literally in an office building or whatever. But take us through in terms of what we track, right? Like the non-core market, if you will, right?
yeah,
Is I assume we're seeing a lot of expansion there as well, and why
Yeah,
that
for
is.
sure. Yeah, no question about it. No question about it. And especially when it comes to AI, we're seeing a lot of places that we never, frankly, would have even thought to see on
Hmm.
a network map popping up as data center locations. And a lot of that has to do with kind of the greater flexibility in where you deploy training architecture, I guess. But
Hmm.
so West Texas, lo and behold, has become like this big area, and it's not just Abilene, it's like multiple points throughout West Texas where operators are scrambling to attach to the gas pipelines and run mini-gen to supply their own power generation at the sites.
So
So
it's
we
very much
see
a fuel play, basically, right?
it's a fuel
Yeah,
play. So
yeah.
this there are, it's not just this, and Stargate has more than just Abilene too. They have
Hmm.
Shackleford County development, Millam development, Google and Caruso separately from the Stargate project. Google Caruso separately from the Stargate project is doing another one. Core Scientific. There are multiple operators, flocking to West Texas. Then you got the Columbus area, which has been something of a strong tier two market for ages, but it's also in terms of network connectivity, but it's also long been kind of a hyperscale hub that's still continuing to just boom.
Mm-hmm.
Everybody is still building there. Google, Amazon, Microsoft, Vantage Stack, Stargate, everybody's building there. And then we have others cropping up. There's been a lot of activity in the Richmond, Virginia metro recently, in Atlanta and Houston and other places. So I'm talking a lot about the U.S. markets here, and
But
to
that's where
kind
a
of
lot of
drive that.
growth in the AI
Well, to
business is
drive
still, right? So
to
yeah.
drive that home, the U.S. has more sites in near-term development than the next 10 countries combined.
Wow. Okay,
So
that's
there
I
you
think that's
go.
worth putting a pin in there, right? Yeah,
That's
absolutely. And
just let that sink in for a moment,
mhm. And it's interesting because
more than the next
Patrick,
10 countries combined. Yep.
yeah,
Yeah. Go
Patrick and
ahead.
I got in a little bit to how, the training is really like almost like campus or at the very least metro specific in terms of the demand. You don't train across large geographic spans, and then once you have a model, it's
No.
pretty easy. So
Yeah.
we are probably going to see. It's almost like what's old is new again in terms of like when the hyperscaler concept originally arose. It was very much focused on the U.S. and Western Europe, and then we're seeing AI very much focused on the
Yeah.
U.S. and Western Europe. Then that
Yeah.
satellite as things change. But while you're doing the training, that's happening here where the engineers are and where the companies are and that sort of thing. It sounds like.
Yeah. Right. So, but to kind of expand on that though, and talk about the connection between that and what's happening elsewhere. So, what's really driving this U.S. centric growth, of course, is our control of the AI market. We got,
Mhm.
and it's not just NVIDIA, but it's like the TPUs from hyperscalers like Google and Amazon too. A
Right.
lot of this development is being run by U.S. based companies. But that said, we're also still seeing tons of announcements in other countries, lots and lots of announcements. And what's interesting is that some of that, especially at the AI level, a lot of that has to do with relationships with the US. There's this
Mm.
geopolitical aspect to it that has to do with, how friendly you are, like what level of ally you are with the US, and then what that does in terms of your access to the latest NVIDIA chips. So, I was just reading about um, this consortium called the Pax Silica, which which is a block of countries that are agreeing to work together when it comes to AI and chip development stuff.
uh,
So, of course,
I,
that's
I love it.
U.S. and Japan, South Korea, Singapore, Israel, Australia, UK, Qatar, UAE, Netherlands, Taiwan.
That
So,
is very
you
interesting.
look at stuff
Yeah.
happening in those places, Pax Silica, but then you also have other countries that we have big deals going on with too, like Saudi Arabia with their humane platform, and
Mhm.
Brazil and India and the Nordics have big deals as well. And I know in some cases, um, it may not necessarily be because of a direct partnership between the countries, but because a country may, or a specific operators may have ownership shares in U.S. based companies that give them access to what they need, or secondary partnerships that enable them to get the supply they want. So things like that. So it's not just these direct partnerships that enable the flow of chips. It could be secondary partnerships too. Like I partner with this company or own this company that gives me access to everything I want. So it can be relationships like that too. So we're seeing, all kinds of announcements in other countries too, and it's largely based on, access to these chips.
Yeah, that's fascinating. So to think about, if you're looking at, sort of like who's best poised to take advantage of all of this, that there's extra layers of understanding of who's going to get access to the infrastructure.
Yeah, it's right. It's not all about like it's not just something you can benchmark based on digital infrastructure metrics. There's this whole geopolitical component as well.
Yeah. Excellent. Well, Jon, this is really fascinating, but I'm going to have to do to you what I always do in these kinds of episodes, and that's make you pontificate a little bit, right? So I understand that the difficulty here, of course, is that it remains unclear what consumer and especially enterprise adoption of AI tools looks like and develops. But given what we're seeing right now, what are you expecting to see unfold for the rest of 2026? Particularly, again, that's how I phrased it to Patrick as well from his side of this fence. But as you're undergoing this research with our summer interns right now, for example, what are you expecting to get out of that research process and see things develop throughout the rest of the year?
Yeah. So yeah, short term, I I can't help but think that at some point we got to be moving towards some kind of a bubble burst. There's just way too much circular investment, and not everything can possibly be that's being announced can be commercially viable, and can be monetized well. So I mean, it's there's this is just seems inevitable. And I was thinking about this especially the other day when I was reading something. I mean, Tech Capital had a really good article the other day. Um, about this SpaceX IPO that's coming up this week. And when you look at like the time, the timelines of things that have been announced, it's just like, how can we continue with this kind of pattern before something breaks? So SpaceX fully acquires xAI in February.
Mm-hmm.
And then it enters two deals in May and in June with Anthropic and Google.
Right.
That basically drastically alter everything about their financials, just as it's getting ready for the IPO. Massive deals. But not only are they massive deals, but these are potentially temporary GPU deals, a couple years at most, that may or may not be fully executed.
Mm-hmm.
So the valuation that goes into that, as they're getting ready for this IPO. It just seems it's just like this one picture of so many things that we're seeing across the market, and how these companies are investing in each other to kind of bolster their values. It's hard to imagine that we're not moving towards some kind of a correction.
Mm-hmm.
So that's probably my biggest anticipation for 2026. But
well, you brought this up, so I have to follow this little string too, which yeah, I mean certainly, I think that's worth thinking about in terms of just the recursive investment and the amount of the S&P 500 that these account for, right? But leaving that aside, just thinking about the physical realities here, it's in the public zeitgeist now of like data centers in space. I'm a pretty deep skeptic of that. I'm guessing you are too, but I want to get your take on it.
Yeah. I don't even know how to address that. People, I forget what people were talking in Slack about this the other day in the company, right? And how there's something about the vacuum of space that makes it impossible to actually
very
expel
difficult
heat.
to diffuse heat in space. It's been a
things
problem
like that.
for space
all kinds of very
since the beginning.
fundamentally
Yeah.
crazy problems that would be
Yeah, and I always think
insanely
that in
hard to
terms of
overcome.
spectrum and latency, is just
Yeah.
the spectrum is limited.
Well, that's right.
You know,
And then, yeah, the connectivity portion alone is just,
yeah,
incomprehensible. So
right.
yeah,
Yeah,
yeah. So it's a weird
I think we
proposition.
can say that surprising things can happen, breakthroughs in
Sure,
technology, whatever,
no
but
question about it.
the
It
world
won't be the
being,
norm.
yeah, exactly. It's real hard to see that. I mean, just like people always ask us in a similar vein, like, oh, are satellites gonna replace the submarine cable market? And the answer is no, right?
Yeah,
No, not in any future that we can foresee with current technology and that sort of thing right now, right? So
yeah. But
yeah.
like, but short term, possible correction aside or whatever, of course, the bigger fact is that the industry will continue to grow and evolve, and AI deployments will be a core part of that for sure. So when we look both short and medium and longer term, I think we're going to see. I mean, so starting early to midterm, I'd say we're going to see growth in training facilities across all
Mhm.
kinds of markets where gas can be accessed, not
Right.
just where the pipelines exist, because there are exclusionary zones where you can't
Hmm.
access it,
Hmm.
but in the zones where you can access the gas, we're going to see more training facilities develop. So that's one thing. Of course, that will create bottlenecks in gas supply as the industry rushes in. So that'll be interesting, to see what it does to gas markets. Longer term, we're going to still be racing towards SMR development,
Hmm.
whenever that takes off. And then also, we're going to start to really see this shift towards inference deployments and sort of secondary training deployments, which we're already seeing, where you have these gigantic LLMs being trained in these remote locations, but then you have on a more localized level, for individual countries, for individual language applications, you have much smaller training deployments happening in commercial data center facilities that aren't these gargantuan projects, just
Right.
more
Right. Where you
normal,
don't need the
typical
latest
co-location
NVIDIA.
environments.
Yeah. Right.
Right.
Yeah.
And so you will see a lot more of that and a lot more of the inference. And so, and with that, we're going to see like a sustained shift in how data centers are designed to enable heavier floor loading capabilities, to enable access for direct-to-chip liquid cooling, and air cooling to be deployed side by side. So we're going to see that happening all over the place. But I think, but then the other thing I kind of think, like medium to long term, is just going back to the geopolitical side of it. We're going to see lots of training deployments popping up in these packed silica locations and other areas where we have where individual operators have agreements with operators that are in allied countries, where they have heavy access to NVIDIA chips. But then we'll also start to see, at some point, I think, kind of a geopolitical AI arms race with China. China's going to catch up at some point on some level, refine
Hmm.
its own development, and form its own alliances.
Right.
Because when they see, they certainly are paying close attention to what's happening. So we'll see them jumping into this as well.
That is, I think it's really fascinating that there's you know, there's some analogic reasoning that brings you back to a space race kind of situation, right? That's at least possible, however
Yeah,
different that is in many respects. But yeah, I see it very much the same way. But I guess I would also say that there's this dynamic that behind all of that also is just this like fundamental question of what we actually get out of AI as users, as enterprises, and how that unfolds. And there's a big range of possibilities there, right? So
yeah,
I think that like when thinking about all of this stuff from an infrastructure standpoint, I sort of mentioned this with Patrick as well. There's like sort of two sides to that coin, that the infrastructure can be the bottleneck, but it can also facilitate, right? You know what I mean?
yeah, for
So
sure.
yeah. So in
Absolutely.
other words, really, any good analyst will tell you that that predicting the future is a fool's errand in many respects,
Yeah,
but it's also what we're
indeed.
asked to do all the time, right? So
Yes.
I think that the only thing that is certain is that that the world is probably going to look pretty different than it does now in a few years. We just can't quite know what that is, right? So,
Yeah,
yeah,
indeed.
excellent. All right. Well, I look forward to keeping up with it. So thank you very much.
Yeah, thanks for having me.
All right. Cheers. Thanks for listening. TeleGeography Explains the Internet comes from the experts here at TeleGeography. It's edited and produced by Jane Miller, and it's hosted by me, Greg Bryan. And I also wrote that theme song you're listening to right now. To learn more about our data, jump over to telegeography.com, and we'll see you on the internet.